Okay, so what if I told you that a discovery just came out that completely shatters a fundamental rule of quantum physics? We're talking about a breakthrough that could rewire everything we know about satellite communication and maybe, just maybe, be the key to a brand new quantum internet. And get this isn't some far-off sci-fi dream. It's happening right now.
For the longest time, the conventional wisdom was, well, pretty simple. Quantum communication from space was strictly a one-way street. It was called downlink. The idea was you had to build these enormous, ridiculously complex satellites, create these super fragile quantum signals up in orbit, and then very, very carefully beam them down to us on Earth. You know, using that spooky property, quantum entanglement, where two particles are linked no matter how far apart they are. But sending a signal the other way, from the ground up to space? Piff, forget it. Everybody thought that was pure fantasy and a story.
All right, so why? Why was everyone so sure this was a dead end? What made sending a quantum signal up seem so completely impossible?
Well, just look at our atmosphere. It's a chaotic mess, right? Trying to send one tiny, fragile particle of light, a single photon, from the ground all the way up to a satellite. That means punching it through the thickest, gnarliest, most turbulent part of the air. The thinking was that air molecules, clouds, weather, even just a little bit of light pollution, all of it would just obliterate the photon's delicate quantum state. The journey would be impossible. It's not like whispering a secret across a hurricane. It's like trying to get a single soap bubble through one.
And then, someone threw the entire rulebook out the window. A team of researchers decided to actually test that assumption, to really push the boundaries. And what they found? Well, it was a total shock.
Here it is, the big one. A team down at the University of Technology, Sydney, led by Professor Simon Devitt and Alexander Semate, they proved that the impossible was, in fact, totally possible. They showed that you absolutely can punch through all that atmospheric noise and send a quantum signal from the ground straight up to a satellite in orbit. It works.
Now, to really get your head around how difficult this is, just listen to this analogy. It's like having two people on opposite sides of a city, and they each throw a single grain of sand at a speeding bullet, and both grains hit the exact same spot at the exact same instant. I mean, we are talking about firing single photons from two different places on the ground up to a satellite that's zipping along at over 20,000 kilometers an hour. The precision it's just mind-boggling.
And the really incredible part? The thing that makes this a true game changer? The team's models accounted for everything. They weren't in some perfect theoretical lab. They factored in all the real-world messiness, like pollution, atmospheric turbulence, the fact that equipment is never perfect. And their conclusion was crystal clear. This isn't just possible, it's doable. Right now, with the tech we already have. Okay, so this is where things get truly revolutionary. Think about it. If you can do all the hard work down here on the ground, it completely changes what you need to send up into space. It basically flips the entire economic model for this stuff on its head. Let's break it down. The old way, the downlink model, that meant launching these billion-dollar behemoths into space that had to do all the super complex quantum processing in orbit. If one tiny thing went wrong, you've got yourself a billion-dollar paperweight. But with this new Uplink model, wow, all the heavy lifting, all the complicated stuff happens right here on the ground. You've got all the power you need, and you can tweak and upgrade the hardware whenever you want. The satellite, it just has to be a simple, cheap mirror in the sky. We're talking millions of dollars, not billions.
Professor Devitt really put the ultimate vision into perspective. He said in the future, quantum entanglement is going to be a bit like electricity, a commodity we don't think about, we just plug in our appliances and use it. Just let that sink in. A practical, affordable quantum network is the first big step to making quantum power a utility. Something as simple and available as plugging your phone into the wall. Imagine having that kind of power on tap to solve problems that our best supercomputers today can't even touch. But of course, a breakthrough this huge doesn't just happen in a quiet lab somewhere. Oh no. This has officially kicked off a global race. We're talking about nations competing right now to build the infrastructure for the next internet. So who's in the running? Well, China has been a major player for a while. They launched their Messias satellite way back in 2016 and have built a massive quantum link. But this new discovery from the team in Australia, it completely changes the playing field. It makes building these networks so much cheaper and more powerful that it could let other countries, leapfrog right over the existing tech. And you better believe the US military and a lot of other folks are watching this very, very closely. So what's the end game here? Why are we even doing this? Why build a whole new kind of internet? The answer is simple, because it's the foundation. It's the essential plumbing for the next great leap in technology. Think of this discovery as the first domino to fall. Okay, so the uplink breakthrough makes a real practical quantum internet possible. That internet then lets us connect quantum computers all over the world, creating a kind of quantum cloud. And once we have that, that's when the magic happens. That quantum cloud makes the insane power of quantum AI accessible to researchers everywhere. Suddenly, we can simulate new drugs, design new materials, and understand complex systems in ways we can't even dream of right now.
And that really brings us to the big picture. Right now, everyone, and I mean everyone, is fascinated by the explosion in artificial intelligence, and for good reason. But there's a second revolution happening right alongside it, almost in the shadows. We're quietly building the infrastructure for a totally different kind of intelligence, quantum intelligence.
Look, this breakthrough just hit the fast-forward button on the future. It takes the idea of a global quantum network out of the realm of maybe someday and turns it into a real-world engineering challenge for right now. And it leaves us with one heck of a question to think about. We've all just lived through the decade of AI, but thanks to breakthroughs like this one, we might just be about to step into the decade of QI.